So first of all, I want to welcome everybody to my talk, Transforming swiftui to JSON and vice versa for fully backend-driven UI, when you need that extra bit of flexibility. I'm hoping everybody in the room can hear me well, and also the folks remotely. If the folks remotely have an echo or anything like that, I'm more than happy to, again, give the talk online on Slack, and if there's any questions, feel free to reach out. I also like to take a minute to introduce myself for those of you that haven't met me during the past years at 360 or at anywhere else. I've been developing IS, or back then the iPhone OS, since 2008 to 2009. I'm originally from Germany, but I work in the US now for Betterment, which has offices in New York. We'll come to that in a second. I very, very much hate the work where you have to work on small bugs that's move that UI button 5 pixels to the left or to the right, or make it a different background color. And we'll talk about that in length today. If you have any questions, like I mentioned, my DMs are open on Twitter at CaffeineFlow. And as can be seen on this picture, I'm obviously a dog fanatic, so if you don't have any questions per se about my talk, we can always talk about dogs, which are great. Since Betterment is sponsoring my talk here, I'd like to take a second out of my talk to talk about what Betterment is. We are an investment IRA and 401k provider with best-in-class automated investing strategies. We have a really strong engineering team and culture all across the US, with offices in New York, Philly, and Denver. There are remote positions available, and we are currently hiring, as what seems like any other company does. But if you are interested, feel free to reach out to me and we can talk. Before we dive right into the talk, I wanted to make a few things clear what my objectives are here. Joe already talked about the pandemic a little bit. I don't have anything to add to that, but I want to say, I want to make it entertaining. This shouldn't be like a chalkboard kind of style lesson. I don't want to make it informative, and I want to make it fun. I want to make it a little bit like Ted Lasso, right? Just that Ted looks a little bit different, comes from a different country, and I'm not as good looking as the original actor. So let's dive into the topic. What am I going to talk to you about today? What we are going to look at today, right? We want to look at how you can make a swiftui app with JSON. So far, nothing special. I'm pretty sure everybody's underwhelmed at this point because that is a problem that has been solved many times before. That is a problem that there's tutorial all over the place. And we're not going to specifically talk about the easy part about it. We're talking about different methodologies and different technologies you can be using, and how to best do it in different scenarios. So if we want to look at how you can build a swiftui app with JSON, there's basically two different ways to create a swiftui app. If we're looking at the very first part that we can do, it's configurable or parameterized swiftui views. You essentially have a view that is a swiftui view that you can initialize with a item, or that you can initialize with a certain type of your model backend data structure, and the view itself knows how to display the data structure that you give it to. You can even enhance that a little bit if you have an observable object backing it. You have the reactive kind of style where your UI updates when the data changes, right? So let's say this is the first kind of methodology or first kind of technology that we can use, or way to implement a swiftui app with JSON. If we were to look at the next evolution to it, or the next iteration towards what we've just seen, then we can enhance that configurable views a little bit and basically have logic in place that then again, based on the bindings or based on the logic that you have in the view, shows different contexts based on the environmental variables. So you're using your shipped views, right? And I want to emphasize the point shipped here. The shipped views that you ship to the App Store to create a screen or to create different screens. Here are selected items again. So let's look at each one of these methodologies real quick, and then we come to the third one, which I want to spend the majority of my time on today. So if we were to implement the parameterized swiftui views or configurable, these terms parameterized or configurable are interchangeable, then we might have a view. Here, we just have a title view that looks like this. If we are rendering it, we can put that into a list, which then would look like this list. And if we were looking at it on a screen or on an iPhone, that's what it would look like, right? And so the parameterized views are the simplest form of creating a swiftui app with a backing data structure, or with JSON in this case. It initializes a view from the backend data structure. It works very, very nicely if you have static screens and you don't need to change your screens at runtime. It's a very clear implementation experience because if you look back at the screen here, right, it's essentially just like the initializer for the view takes the data, and then you are free to use your backend logic to complement your screen the way you like it to. Again, I've said it, I don't want to spend my whole majority of time on this. There are plenty of tutorials on the internet, and I've pointed out 3 of those that will help you to get into this if that's something that suits your use case. The second part of what we are going to talk about today are the dynamic screens with shipped views. So this is a little bit the next evolution to this, right, where we have parameterized views or configurable views that then again have the logic baked in or the logic externally that shows you how to create it like from many different smaller views that you have in your app bundle at the time that you publish it on the App Store, a new screen. In this case, we have like a login screen, and we have a home screen, and we have logic in place in the home screen that actually shows if like the user is logged in or not. It would be showing either optionally the login screen if you're not logged in, or the home screen if you're logged in, which then again, based on the input, the logic or API, and this could be anything at this point, right? It would be looking like this, that you might have like your login, you type in your username and your password, which is very hidden in this case, and you would get to the home screen based on that logic. So very simple in this case again. But this is basically all what you find on the internet these days, like the tutorials what most of the swiftui apps are today. Asking in the audience, has anybody like used swiftui in production already? See a couple of hands. Is that covering 90% of what you've been doing, or are you going way beyond what I've just said, or what I've just explained? I see a few head shakes, and people seem to be, it's early on, so I'm assuming I'm right that I'm saying this is about 90% of the use cases that people are using. To summarize this again, it's an evolution to the parameterized swiftui views. You're capable of composing whole screens from a set of shipped views. And it can be as dynamic as consuming another API at runtime to describe the full screens. So you could write boilerplate code basically around it more and more and more and more over time, and you would be having more and more statistically, if you're looking at it, you would have more edge cases coming with it, you would have more possibilities to ship your views, which would be great for your product manager because you can come to your product manager and be like, we have 1,000 shipped views now. That creates 10,000 possible configurable views, which creates $1 million. More follow-up resources on that. But to my rambling on that, do you hate these UI bugs? Do you hate these like edge cases where something doesn't work or looks like weird or funky on an iPad? Or do you not like having to work on these UI bugs later than on in your backlog? I personally said it when I introduced myself. I don't like that, because if you take an interview today as an iOS developer in most companies, you're usually not being asked to code a button 5 pixels to the left or right on a whiteboard. You're usually being asked to like work on very complex and abstract issues, and then your day-to-day job, right, looks very, very different from that. And I found this very disturbing. I found this very to be abstract from reality. And so wouldn't you rather spend your time on actual features that you interviewed for? I think we all do, and Apple certainly does. And let me show you how we did it and how you can do it too, to make a very fluid, a very flexible swiftui view, or views of your whole, that composes your whole app, where you wouldn't have to do these things and re-release an app just for a pixel or for a button to be moved 5 pixels to the left. So how to do it? If we have our swiftui views, there's one thing that stood out to me very early on when we were looking at swiftui, that all views are structs. Why is that something that stands out to me? Because if you use structs and you use codable, it automatically synthesizes the codable features. So decodable and encoding from and to JSON is automatically synthesized if your underlying properties are also encodable or decodable. So in general, we can just encode a view. Now, so this is the next step of evolution, right? If we're looking at it from a codable text, we could create a codable text that is not encoding and decoding the data that is being displayed in our view anymore, but it is encoding the view itself, right? So if we're looking at it from an expanding brain meme, right, style, then the first part is, like we said, the simplest form is the static screens with parameterized views. The second part is, or the second evolution to it is the dynamic screens composed of shipped views. And the third part would be encoding views itself, right? So in an evolution of these, we are going from simple to more complex with boilerplate code, and then to be like, oh, scrap that. We're just like encoding the full thing. We're just encoding the layout fully, which would give us a fully fluid and fully flexible swiftui view, right? So we could be changing things from the back end. So let me show you this one weird swiftui trick where you can do that. Where we have on the left-hand side, we have our JSON backend data structure that is being monitored or consumed from my encodable swiftui view on the right. And every time I'm saving, it is just like literally like reloading the swiftui view. So very simple logic that we can easily replicate. Right now, we just have a text that is even like a line break in it. Now we're putting the text into a VStack that is described in our JSON. We're putting it underneath each other so that we have several text views underneath each other. And once I'm saving, it will automatically update without me ever having shipped anything else than a very generic swiftui view that just takes JSON input and displays whatever I give it to. I'm going to let this run for a second so we can actually see the results. All right, and it automatically updated. We're going to see more of these demos in a second. And there's also like a playground and a whole Xcode project that's backing my talk that we'll share with everybody after the talk, where there's a lot of these examples in the Xcode project so that you can relive everything and like look at like how it's been done. But if we're looking at it just from an architectural perspective, then we have our JSON that is now no longer describing the data that we are displaying, but it's describing the layout. It's a bare layout backing structure, and it can go down as much as like you want it to be, right? Like if you wanted to encode every single swiftui view that Apple delivers with the iOS SDK today, you could do that and could literally recreate any view that you would usually create at compile time and deliver to the App Store. You could create that from a backing data structure in JSON and change it at runtime, right? So your app, if you would have the next time your designer would come to you and tell you like, oh, this button has the wrong background color. Can we change that? And you're like, yep, it's going to be in hotfix 110. And you're just having to release it and spend your day on that. You wouldn't have to do that anymore. You could just change the JSON data structure, and it would automatically do that because the JSON data structure is essentially your layout. It's essentially what your view looks like. So you would have your JSON data structure going into your deserializer or your view factory, which we're going to look at in a second. The deserializer, the view factory, would create your swiftui views based on the encodable and decodable swiftui views that you have, which again could be the Apple's swiftui views, and that is going to be shown as your decoded swiftui view. If we are now looking at like what this could be in a larger picture, right, then you could even put this in the next step of evolution, where you have your user input, the diver clicks the button that he wants to see the home view, or wants to see the loading view, or wants to see your product view. That request is being made to the API server, which could include parameters like page, device type, a version of the app, a special A/B feature testing, or anything like it. The API server, which could be anything you'd like, right? In the time where we implemented this tree would be built up at the end of the day when you were decoding it as a list, a stack, the image, and then your text to it. Compiled in the app, it would look like this, that you would actually just showing it at runtime. It would fetch the URL, it would fetch the image. You could use anything for the fetching mechanism. I used Kingfisher image for this because it was very simple. And then you have your encoded or codable text, which would show up with any kind of properties or modifiers that you want it to be. And these modifiers could be abstracted too, which we'll come to in a second. And that's it. When we implemented this at a prior shop that I can't talk about much, we were working on this for over a year as a team of multiple people because we also had the level of abstraction that we were like, we couldn't ship the views that we had to at ship times, so we couldn't put these in the app store, so we weren't capable of like doing the second iteration of swiftui where you have like a lot of shipped swiftui views that you would then compose. That wasn't possible because we never knew when things would change, and our team was also known to be very slow with shipping things. And so one of the demands that we had from management was to ever change things like HTML, and CSS was doing it. And so what we also wanted to do, what the other issue was, is that we had an Android team that was as slow as we were, or as fast as we were. I don't want to be mean. So they were as fast as we were, but there were always like discrepancies that we had between iOS and Android, which I think is very normal in some terms, and sometimes they are even like different personas and you want to have these different. But for these views that we were presenting, we knew we wanted these to be the same. They should look across the same across HTML. They should look the same on iOS and on Android. And so what we did is we put in a level of abstraction where our JSON API, where our data structure could be as fluent as either be differently for iOS and Android or the same. We decided for it to be the same. And so we decided to create a codable variant that is then consumed as a model. So you would have a view model-like structure where you would abstract the model for the view that's backing your data or your layout structure. And then you encode it into variances of the same model within an enum. Kind of a little bit like a Loki variant, but it's a codable view variant, where you would then have your text component that's decodable, which had all the different parameters that you needed or all the different properties that you needed. And then you could abstract it to the point where it would be the same between Android that was using Jetpack Compose and swiftui on iOS. And you were then like putting it just in this model, and the model would be basically consumed. And that's what I've been saying earlier. You could even have like a modifier that is a common text modifier or a common base modifier that just applies to everything, because all of these are different variants. I've put a link down here to Swift by Sandel for handling model variants, because that's essentially what we use to abstract these things. And it's a very nice tutorial about how you can put these things into associated values for your backend structures on an enum, so that you have different enums and could decide on those. And the deserializer would be rather simple then, because you would just implement a decodable and change on the type string that you have on your JSON API on which kind of model you're building up, and you would get a list or a text or a button in this case, which I've implemented. I've also implemented the VStack as we've seen earlier. And then all you would be doing is would have a view factory with a static function that takes the codable view and outputs the view with the model for you. Very simple, right? So let's look at the next example that we have here, where we actually go in and do a little bit more work here. If we look at the sample that we had before, we still have the two texts now that we're here in a VStack, but let's say we want to change that and create an image instead of the text from the first. We'll just simply change the type towards image from text. We add an URL to it, which is again just image that that is on the 360 homepage. We also change the text. Right. And as soon as we changed it, the text actually changed, the image came up, and it would auto lay out everything that you had with the alignments that you wanted it to be. But let's go a level deeper and actually make it a list so that we would actually show different things and more of that. I've just copied the JSON from a different tab here, saved it to my file that was being monitored, and we have the text in a list. Now we actually gave the list another headline. So we actually implemented 2 days 360 IDEF schedule, which would be our keynote speaker, Joe Kaplinsky, then myself with swiftui via codable, and we even put his image underneath in a VStack that has a list and an image and a text without ever having to written anything or having to click the compile button on Xcode, wait half a year, take your phone out, check Reddit, go back, everything live here without ever having to click compile. And while I was initially thinking of cutting these with Final Cut Pro, this is the live demo that I did last night in my hotel room, so there is no like in between that you really didn't see. The big question that some of you might be asking is though, like, how do you create like valid swiftui JSON code that is not going to crash your runtime at the end of the day when you're on mobile, right? Or when you have it already released and you just get like a bunch of crash reports in from Firebase or whatever your like debugger is or your crash reporter is. How do you do that? So there's several types of things that you can do, and that was a big issue that we had, right? I've mentioned that in one of our main objectives was to translate basically HTML, CSS into the same views in native, right? And native land was very important for us, that we would have everything in native because we didn't want to put it in a web view at the time. So one of the things that we could have done or that we did is like you could just write your, and we're looking at this in a video and again in a second, is write your swiftui views as you would usually do. You add like an on-tap gesture button to it and then you just encode it, right? Which is exactly what I'm doing here, where I have my views already built out at runtime, at compile time. So I compile it, I look at it, and all I'm doing now is like adding a on-tap gesture to it to encode my whole view, and then the view is being printed out to my console, which already gives me a valid JSON code as I know it. That can go as far as either encoding your codable structures, right? So your codable views that we've looked at earlier, or it can go as far as, again, like adding extensions to the swiftui view types that Apple gives us, which I've did in many times. Sometimes you have the problem that a property that you might need to access is private and you don't see it, and which is a big issue sometimes when you're implementing the encodable. But what you could do to go around that is, like, if you're working on multiple platforms, you could use swiftui introspect to actually get the underlying UI kit view that's being implemented by swiftui and get your property that was private. Or you could like use your codable text. For example, text was such an issue because it didn't have the label property actually exposed, but the UI text had the UI label had the button the label exposed. And so you could definitely use swiftui introspect, which is a library available for these kind of things, to get these private properties that you would otherwise not get. So you just encode, like at our standard views, or you encode what you need. Here in this case, this would be the codable view, that Swift that we've seen earlier. And then you just grab the JSON output from the console, or you write advanced tooling for it. And that was also pretty much like one of the key points that we're coming to in a second is like you live and die with the tooling that you create in this case. Because you are moving everything to the backend and you are working cross-department and both teams are working essentially half in whatever your backend language is and half in Swift. And so you need to have like strong tooling, strong error outputs, and strong communication between the teams to actually make this work or not. It is server-side rendering essentially, which is nothing new in the React world. But in the Swift world with a strongly typed language where you have to encode and decode everything, it becomes a hassle. And that's also about what it is with the pros and cons coming to the end of my talk. If we're looking at the pros and cons of this talk, or looking at the pros and cons of the swiftui server-side rendering, there's a lot to do here, right? So what's very nice is that, like I kept saying, is like we can reimagine app screens on the fly. You're no longer bound by what you are going to ship to the App Store. You are very flexible. And this is, like I keep saying, we are not the first one doing it. React has been doing it for a long time. Some of you might know that that Spotify has been doing this for many, many years, even in UIKit land with the Spotify Hub framework. And you might also be wondering what's going to happen at the review time when Apple is going to review your app. would they be happy at like seeing different screens when they're actually in the App Store, or would they be happy if you're like giving different screens for review than you're giving to someone or giving to the actual users? They might not be as happy, but if you use it within the realms that your app is working at, then I'm sure this is a great technology, and this is actually something that made it into the App Store for my prior employer, where server-side rendering really enabled us to do all these kind of things that product wanted us to do, which was these very fluent, these very fluid swiftui views that would actually reassemble whatever HTML and CSS was doing for us on our homepage. So if we look here again, like you would be sending the requests to the REST or GraphQL server. GraphQL kind of like was a little bit of a bad choice initially for us because everything is hierarchical and you have like this hierarchy building up, which GraphQL didn't work too well for us initially, but we made it work by serializing everything into a linked list essentially and then like reassembling it on the client, which also enabled us to be able to ask from the client what the client wants to see rather than just getting us like a shared layout, which made us able to have like different versions for Android versus iOS from the same API endpoint. And then also you could imagine like expanding that to macOS or any kind of other client that you wanted to have, which was even better when you were bringing the iPad in because the iPad had a completely different layout for us. And so we were able to also separate for the device type for that from the same thing. So measure once, cut twice, or measure twice, cut once, right? It's really the question here that I keep thinking about. I've mentioned boilerplate code. That was the biggest thing in my mind. Like every time you write code, it becomes boilerplate the second you ship it, or it becomes legacy code that you have to maintain. So like I said, you could potentially do what we've done in enough API if-else clauses, right? Where you would looking at like consuming an API, put 100 if-else statements in there and just have that, but that would get you to write all these boilerplate codes, which adds complexity, need for maintenance. This is also a relatively complex solution to the issue, right? Because you are essentially, like I said, moving the front end to the back end, which could become an issue at one point. So you're adding complexity, need for maintenance, and additional edge cases, which could very well cut yourself. You could cut yourself in the fingers rather than like helping everybody else if you're doing it. My wife kept saying when I was like making this introductory talk to her about like how swiftui works on the server side that I keep to put everything into the negative, so please don't put everything into the negative. I think if you keep these lessons learned in mind that every layer that you add as a complexity or is an additional complexity and you keep things simple as much as possible, then this is very well a great technology to have simple screens, like a loading screen, a home screen, or anything like it, to be a native and to be as flexible as HTML and CSS. And especially if you iterate quickly on and you're a team that is already known to work well together, then I'm pretty sure this is like a great possibility for you to no longer having to solve all these 5 pixels left, 5 pixels right stories. And like I said, I keep reiterating strong tooling to help debugging and communication is the key to this. So in this matter, keep it simple, stupid, where possible. Since we are talking about server-side rendering again on a client that isn't meant to be server-side rendered. So I always liked this comic a lot. This was always how I felt like in pretty much every other meeting, where I was always like, oh, we're just going to add this one modifier that is now making this specific view work. Which always had me thinking about like, so why didn't we do this in place if we're like having to add all these modifiers and writing all this boilerplate code? And so oftentimes I kept asking, so aren't we just at the point where we like reinvent HTML and CSS with extra steps? And normally I would never get like a single response to that. Normally I would just get the angry faces and then people would like avoid me for a day or two until I would keep asking, so did it hurt your feelings that I wanted to bring in HTML and CSS in a native app? And oftentimes I think I've hurt people's feelings, which wasn't too good for myself. But the point what I want to make here is like you need to reiterate what your purpose or what the technology is that you want to use. What is what you want to display? If you really want to have everything from HTML, CSS, and native land, think about like why you're doing it, and if you can't just like use the technology that already exists that someone else is curating already for you, to make the purpose work for you. Technologies have been invented and different languages have been invented to solve different problems or specific problems, right? So Swift is not a general purpose language that you can do everything with it. It gives us a lot more capabilities than Objective-C was giving us, but it's not meant to do everything like that. So with that said, like swiftui very much is a step on top of the UIKit stuff that we were doing, because we could do everything that I've showed you in UIKit. It would be just tremendously more complicated. But as soon as you're putting your own, like yourself, like the complexity on top of it by putting in a SYN translation layer or putting in anything else like on top of it that you might not need, or you're missing your use case, then it becomes very burdensome and you might just miss the use case for that. But to give you a lookout, like I'm not the only one doing this. We were not the only one doing it. Just as I left my prior employer, tutor.app was released, which is essentially making this promise build native app experiences with no code. And I was looking into the package structure. They are essentially just putting all the UI that you're creating in there. What you see is what you get style of editor. They're encoding that into JSON, have local image assets to it, and then they're loading it in their host app, which essentially just reads the JSON and builds up the swiftui view again, the same way that I was showing you again. Then I mentioned the Spotify Hub framework, which was doing the exact same thing with UIKit, and which happened to be also the very same thing, or the very same schematic and technology that we were using it prior to the swiftui stuff that I've just shown you. Unfortunately, that is deprecated now, so that is no longer being maintained, and it's been deprecated for a while, but that's probably because of the UIKit stuff. And some of you might have known JSON.NET, which does the exact same thing, where you write a lot of JSON code, it compiles it, or it actually shows it at runtime, so it doesn't compile it, it translates it, or interprets it into at runtime to an iOS client or an Android client from the backing data structure that is the JSON.NET format in this case. That's it for myself. Thank you so much for listening to me, and I hope everybody enjoys the rest of the conference. I know this was a speed run. I kept the examples very simple because of that. But feel free to hit me up. Like I said, there is this GitHub repo that I've updated yesterday, so there is all the code that you've seen in there, and some examples. Also, like if you're scanning the QR code, you get my business card and an Apple Wallet Pass, which means that you can hit me up on my email if you are interested in talking about this. I'm happy to take any questions now. Yes, I'll start from the right.
Actually, 2 questions. How do we handle like low or no connectivity situations? And the second is how do you handle like stuff like bindings and actions?
I'll do the first one first, and then I'll ask you for the second question again, because I'm not sure if I got that fully. So the first question is, how do you handle like no connectivity or low connectivity kind of situations? So that's a very great question. So the Spotify Hub framework was like, when I was looking at it on Twitter, there were several people that were like, yeah, that's why like Spotify never loads my view controller when I'm on the train, and I have to like turn it into the offline mode first. That's the very same issue that we were having, like when we were detecting like low connectivity or no connectivity. After a timeout period, we were just loading standard views back from the JSON. So we were shipping JSON files with the app that was showing everything in a standard card, for example. We had the issue that like oftentimes like the API might just be a slight tick off of the views that we knew already. And so we were just forcing the data that we knew or we had, right, into a view that was like known at compile time. So we had like backup options essentially that was like like showing the view there and no connectivity options. Can you repeat the second question for me?
I was dealing with stuff like bindings and actions.
Yes, I skipped over that a little bit. So in one of my last slides in the pros and cons, I've mentioned actions and buttons, right? And that was one of my most memorable meetings ever, where people were asking, so what do we do for the save and share button? And what do we do for button actions? And people started to talk about selectors, putting in selectors, Objective-C methods, like object calling and stuff like that. To which point I was like, so it's not only HTML, CSS, but also JavaScript that we're reinventing. And that's essentially what it is, right? Like you can have like predefined functionalities where a button would be actually backed by the JSON through a selector or a Objective-C method calling. But at the same moment, this becomes very dangerous because you're exposing yourself or your clients to if you had a man-in-the-middle attack or anything like that in between, that a button action could be remapped to something else that might show their credentials or anything in that. So that is kind of dangerous, and there is no great example to it. We had a list of whitelisted actions that we could do, which were very simple actions like showing a share sheet, showing a button, stuff like that, right? But I wouldn't go much beyond that, because then again, you're reinventing a scripting language that would help you script a app that you already sent to the App Store. I hope that answered the question.
Yeah, the last part was about bindings.
Oh, bindings. So bindings are rather hard, right? You could do the very same thing where you have a binding and you symbolicate your bindings prior to shipping it to the App Store. And then you would essentially, like, once you get the JSON in, recreate the binding, which you can do from a raw value, which would make the binding work, right? But it's somewhat wonky because, again, like it's based on a string, which is loosely typed. Right. Up front here, thank you. Yeah, so at the time that I was still with my prior employer, there were like plans for doing that, but we were also like about a year late releasing it. So at the time, like we were abstracting it to the level that it could work on both iOS and Android, and that gave us the most headaches because it was the extra layer of complexity that we had. For iOS, we were almost complete with it because initially we were also building a result builder that would just take standard view builder code that you would have in a view. And that part, I think, had been open source released at the time already. I can look that up for you again. The other part, I don't know. I need to connect with the team and see what their plans are. But given that they were relatively late in the game, that might take a backseat usually as one of the first things to cut time. So maybe at a later point. Any other questions in the room or on Slack? Yes.
So you're working on JSON directly, right? So have you considered using function builders so that you can still get a type statement way of creating views that can also then with JSON and also feedback into the project?
Okay, so the question was if we were considering using function builders, right? That's what he said. Function builders to basically build views up at compile time and then like encoding them. Is that the question? Okay, so part of it like is that we were essentially translating everything from HTML and CSS. So we had like engines that were essentially like going through the translation layer, looking at the HTML and outputting swiftui code, and we were like automatically testing it on the swiftui view that you saw with the file monitoring. And if the view wouldn't crash or get an error, then it was not a JSON code for us. At the other hand, what we often did is like we built like the views, and then we had like the encoding structure that I've shown earlier, where you would click on the view itself and would output that to the print. But as I mentioned before, we also had like this little experiment early on that pushed everything off here, where we had like a function builder or result builder functions essentially that would just take JSON structure or put JSON structure in, and so we would avoid the whole translation layer from JSON to swiftui, because it was essentially just putting in the bare text, the bare minimum, that is the view builder describing your view, into a swiftui view and putting that up. So those are the 2 or 3 ways that we were using. The problem really came in because we also wanted to be compatible with Android. We had the abstraction with the model, which gave you the complexity of the translation layer, and then you wouldn't be able to use just the view builder anymore, or you would have to go extra routes and adding complexity to translate the model into the view builder output again. So yes, there were plans, but we drove away from this when we were using the view model structure, and we were using the abstraction to be compatible with Android. All right, I got the signal that I'm at the end of the time. If anybody has questions, please hit me up. Thank you so much again for listening to my talk.